Hello everyone, I am Professor Sanjay Kulal. Today I am delivering lecture on internal combustion engine. My chapter is engine testing and performance of SI and CI engine. Okay, this is the syllabus of the chapter. The first point is parameters, types, test and characteristic curve. This point already studied in previous lectures. Today we are going to study the next part of this unit number 4. This unit number 4 having three parts. First one is parameters, types of test, characteristic curve. Second one is supercharging in IC engines. Third one is engine emissions and control. Okay, the first part is already covered. Today we are going to cover the second part of this unit number 4 is supercharging in IC engine. Okay, this part consists of effect of altitude on power output. Second one is types of supercharging. Okay. Okay, next point, effect of altitude on power output. Okay, the point is effect of altitude on power output. Generally power developed by the engine is utilized for various purposes, but the power developed by the engine is depends on some parameters. Okay, and this power is vary according to altitude. Okay, in this point we are going to study what is the effect of altitude on the power output. Okay, engines are generally designed for sea level condition. Okay, means if you take any engines are designed, means carburetor or every engine parts are designed for the sea level, because most of the engines are used in on sea level, means on ground. Okay, therefore most of the engines are designed on sea level condition, but at high altitude temperature and pressure reduces. Okay, we know that when we go away from the earth or from altitude to the upward direction, in that case the temperature and the pressure of atmospheric air is decreases or reduces. Okay, if you go away from the ground level, the temperature and pressure reduces, means therefore density of charge is decrease. Okay, and suppose if you take SI engine or CI engine, we require some charge, input charge, that is spark ignition engine, we required fuel, air fuel mixture. For SI engine we required only air. Okay, if you move from ground level to the higher altitude, in that case the charge we supply to the engine vary with density. Okay, means suppose if you move away from the earth, the density of charge will be decrease. Okay, density of charge will be decreased, means the mass of charge inducted per stroke reduces. Okay, means the amount of charge inducted during the suction stroke will be reduced because of decrease in density of charge. Okay, the power developed by the cylinder again reduces. Okay, means if you take engine cylinder, then the power developed by the engine cylinder, means the power developed by the engine reduced because of this variation in charge density. Okay, to overcome this problem, engine need to be supercharged at high altitude. Okay, means suppose if you want to use the engine at high altitude, in that case we need to supercharge the engine. Okay, supercharge the engine means the density of air and fuel mixture which is supplied to the engine should be vary according to altitude. Okay, this concept is nothing but supercharger. We will cover this in next point. Okay, next one is supercharging. Okay, what is my supercharging? Supercharging, the process of increasing the inlet air or charge density in order to increase the power output of the engine is called supercharging. Okay, now supercharging, it is a one type of process in which the inlet air or charge density is increased in order to increase the power output of engine. Okay, as we studied earlier, when we move from earth to, that is, higher altitude, the density will be vary. Okay, in order to maintain density, here the supercharging process is utilized. Supercharging process is utilized means here the inlet air and charge density is increased. Okay, next one is supercharger. Okay, supercharger is nothing but the device which is used for the increasing the pressure of the inlet air above the atmospheric pressure is called supercharger. Okay, means the supercharging process, that is increasing the pressure above the atmospheric pressure. Okay, this process is carried out by a separate device. Okay, this device is nothing but supercharger. Okay, generally in supercharger the pressure is increased above the atmospheric pressure. Okay, the next point is objectives of supercharger. Okay, we are going to study the objectives of supercharging, means why supercharging is required. The first one is to increase the power output of the engine by increasing the density of charge at inlet. Okay, means suppose if you want to increase the power output, we should increase the density of charge at intake or inlet. Okay, means supercharging, the first objective is to increase the power output. Second is to reduce the weight to power ratio. Okay, the second objective to reduce the weight to power ratio, means suppose if you take any engine, suppose aircraft engine. Okay, engine is used in aircraft. In that case, aircraft always travel it at high altitude. Okay, in that case we require power, we require more power. But as we studied earlier, as altitude increases, density decreases, means resultantly power will be decrease. Okay, in order to maintain the high power, we should require we should require we should require the supercharger. Okay, means to reduce the weight to power ratio. Okay, means suppose if you want to increase the power, we require high weight engine. Okay, but if you utilize the supercharging concept, then we can develop more power in low weight also. Okay, it is useful in aircraft, racing car and marine application. Okay, generally the supercharging concept is useful in aircraft, that is racing car. In racing car also we require more power. In marine application also we require more power. Okay, in that case the supercharging concept is very important. Okay, next one is to overcome the loss of power at high altitude. Okay, to overcome the loss of power at high altitude. Okay, means suppose as I said earlier, when we move at high altitude, what happen, the power development will be reduced. Okay, this reduced power is covered by using the supercharging concept. Okay, the next one is to reduce the bulk of the engine where weight and space is important. Okay, in some cases there is weight and space is very important. Okay, suppose as I said earlier, when we're traveling through the aircraft. Okay, in that case the engine, the power required is more, but the engine size should be small, or weight of the engine should be small. Or in marine application, in that case we can use supercharging concept uh, for the fulfill the need, that is to reduce the weight. Okay, next one is effect of supercharging. Okay, supercharging. Okay, here two diagrams are shown. Okay, the first one is, this is theoretical pressure volume diagram. Okay, for naturally aspirated engine. Naturally aspirated engine means the engine having not supercharging concept. Okay, next one is supercharged engine. Okay, means here these two diagram, it shows the difference between, okay, what is the variation in pressure volume diagram when naturally aspirated engine and when supercharged engine. Okay, here the first diagram shows that. Okay, here the pressure line, this is volume line. Okay, so here P atmospheric means this dotted line indicates the atmospheric pressure. Okay, so here the process start from this, that is suction, start from this point to this point. Okay, okay, the here the suction is carried out below the atmospheric pressure. Okay, suction is carried out below the atmospheric pressure. Okay, again our compression process, heat addition, okay, expansion, heat rejection process are takes place. Okay, means here the this area, that is area B, if you compare area B, area, the part of area B is below the atmosphere. Okay, and all the area is above the atmosphere. Okay, if you calculate the resultant pressure means mean effective pressure, then this mean effective pressure is calculated by the subtracting the area B from the area A. Okay, here we are showing area A minus area B. Okay, here area B is subtracted from the area E in order to calculate the mean effective pressure. Okay, this is natural aspirated engine, means not supercharged engine. Okay, here this PV diagram shows for supercharged engine. Okay, here what happened, here the first process, that is suction process. Okay, suction process, that is 1 to 2. Okay, this process is carried out above the atmospheric pressure. Okay, means here supercharging concept is utilized. Okay, means the density of air or air fuel mixture is increased, means the pressure of air and air fuel mixture here increased. Okay, means here we are using supercharged engine, means here the pressure is higher than the atmospheric pressure. Again same way here compression, heat addition, expansion, heat rejection process takes place. Okay, but if you want to calculate the resultant pressure, that is mean effective pressure. Then here this mean effective pressure is calculated by using these two areas. Okay, here area D and area C. Okay, but here both the areas are above the atmospheric pressure. Okay, therefore the resultant pressure is nothing but the addition of these two pressures. Okay, means addition of area C, area D. Okay, this is nothing but pressure for supercharged engine. Okay, means here we can get the difference between supercharged and non-supercharged engine. Next point is effect of supercharging. Okay, now there are different effects of supercharging. Okay, some of the effects are listed here. The first one is higher power output. Okay, if you utilize the supercharging concept, there must be an increase in power output. Okay, next one is greater induction of charge mass. Okay, if you utilize the supercharging concept, okay, here the greater induction of charge mass means the amount of air or air fuel mixture set in an engine cylinder will be increased. Third one is better atomization of fuel. Okay, generally in CI engine we require the atomization of fuel. Atomization of fuel means the fuel should be distributed in an engine cylinder through a small fine droplets. Okay, if you utilize the supercharging concept, then the fuel should be atomized. Okay, next one is better mixing of fuel and air. Okay, for combustion for proper combustion of air fuel mixture, there should be we require proper mixing of fuel and air. Okay, if you utilize the supercharging concept, then this better mixing of fuel and air takes place. Okay, next one is quicker acceleration of vehicle. Okay, this concept is also important. Quicker acceleration of vehicles means when we utilize supercharging concept, okay, it is useful for the acceleration of vehicles. Okay, next one is improved cold starting. Okay, improved cold starting means suppose in winter condition or early morning condition, okay, there is a difficulty for start the engine. Okay, if you utilize or use supercharging concept, this improve the cold starting parameters. Next one is reduced exhaust smoke. Okay, reduced exhaust smoke means here when we use the supercharging concept, the amount of smoke which is exhaust from the outlet stroke will be reduced. Next one is increase mechanical efficiency. If you use supercharging concept, there should be decrease in mechanical efficiency. Generally mechanical efficiency means it depends on two power, that is brake power and indicator power. Brake power means the power which is available at the output shaft. Okay, and power which is available at the output shaft. Okay, and indicated power means the power developed at the engine cylinder. Okay, mechanical efficiency is the ratio of brake power divided by indicated power. Okay, if you utilize supercharging, then the brake power will be increased. Okay, means resultantly mechanical efficiency will be increased, means output will be increased. Okay, next one is increased detonation tendency in SI engine. Okay, this is the drawback of supercharging. Okay, when we utilize the supercharging concept in SI engine, there is detonation tendency will be increased. Okay, these are the some effects of supercharging on performance of SI as well as CI engine. Okay, next point is types of supercharger. Okay, generally supercharger is pressure boosting device. Pressure boosting device means which supplies the high density or high pressure air or air fuel mixture to the engine cylinder. Okay, means it boosts the pressure, means it increase the pressure of charge. It may be air or it may be air fuel mixture. Generally a centrifugal, axial or displacement type of compressors is normally used for the supercharger. Okay, as we know, supercharger is one type of compressor. Okay, I mean, similar to the types of compressor here, the superchargers are also three types. First one is centrifugal type supercharger, second one is roots type supercharger, third one is vane type supercharger. Okay, so let us start with uh, types of supercharger one by one. Okay, the first one is centrifugal type supercharger. Okay, centrifugal type supercharger. Okay, the centrifugal type supercharger consists of different parts. First one is impeller. Okay, this is impeller which is mounted over the shaft which is connected to the motor. Okay, next one is diffuser. Okay, second is diffuser. Okay, and this assembly, that is shaft, impeller and diffuser, is located in a outer casing. Okay, this casing is known as volute casing. Okay, here according to shape this casing is volute casing. Okay, next, this is the outlet. Okay, this is the outlet and this is the inlet. Okay, means the atmospheric air which is supplied to the engine is connected to this air inlet. Okay, and this air is passed through the total supercharger, and this outlet is connected to the engine inlet. Okay, means suppose if you want to use supervisor for SI engine, then it is connected to uh, uh, carburetor. If you want to utilize the uh, supercharging concept for CI engine, then it is directly connected to the engine. Okay, here working of this centrifugal type supercharger. Okay, here what happened, the air is passed at the eye of impeller. Okay, air is comes at the eye of impeller. It, the when impeller revolves, the air flows from impeller through the diffuser. Okay, again diffuser direct the air to the casing. Okay, when air comes in casing, okay, the pressure of air will be increased. Okay, initially air comes in at this position, the pressure is less. Okay, when air pass through this impeller and diffuser, the pressure of air is increased. Pressure is increased, the density will be increased. This high pressurized, high density air or air fuel mixture is supplied to the engine cylinder. Okay, air or air fuel mixture is supplied to the engine cylinder. Okay, this is centrifugal type supercharger. Okay, this centrifugal type supercharger is generally used in automotive engines. Okay, about 30% more air fuel mixture can be forced to the combustion chamber. Okay, means suppose if you utilize this supercharger, okay, then the amount of air fuel mixture which is supplied to the engine cylinder is increased by 30%. Okay, generally these impellers are made from duralium or alloy steel to withstand the high stresses. Okay, means high stresses will be developed over the this impeller. Therefore this impeller is designed or made from duralium or alloy steel. Okay, this is the first type of supercharger. Second one is root type supervisor, sorry, root type supercharger. This root type supercharger consists of two roots or two rotors. Okay, these two rotors of same size or mounted at two shafts. Okay, with the help of key. Okay, as I said earlier, these two rotors having same size. Okay, here one is the power is supplied for the one rotor. Power is supplied to the one rotor. Okay, when one rotor revolve, then it comes or engage with the second rotor, and the second rotor also revolves. Okay, here these two rotors are located in a casing. Okay, this is outer casing. Okay, here inlet is provided, here outlet is provided. Okay, here what happen, when we start the supercharger or start this compressor, then what happen, the air at the inlets comes at this location. Okay, here the temperature, here sorry, where here air comes or trapped between these two rotors. Okay, air is trapped between these two rotors. Okay, and as the rotor rotates, this air is moves from this side to this side, that is inlet side to outlet side. Okay, and the pressure or density of air will be increased. Okay, and here we can get the high pressure air which is supplied to the engine cylinder. Okay, next one is vane type supercharger. The third type of supercharger is vane type supercharger. The vane type supercharger consists of different part. First one is, this is drum. Okay, this drum, okay, on which slots are provided. Okay, on the drums slots are provided. This is the body. Okay, this is the body, that is casing of this supercharger. Okay, here the inlet is provided at one side, the outlet is provided at outer side. Okay, here this dark part is nothing but veins. Okay, these are the veins are provided. Okay, and these are the spring loaded veins. Okay, means here the spring are provided. Okay, and these veins are slide in a slots which is provided over the drum. Okay, means this vein slot in and out through this slot. Okay, generally when this drum is stationary position, then these veins, the veins comes out of the uh, drum, and they comes in contact with the inner part of the body. Okay, when this is in start condition, when this is start condition, then what happen? Inlet air, inlet air, inlet air pass through this inlet air, comes in the supercharger. Okay, and this air is trapped between these two veins. Okay, when trapped between these two veins air, then air moves from this side to this side. Okay, here we can see that when air moves from this side to this side, this area is decreased. Okay, as the area decrease, the pressure will be increased. Okay, and here at the outlet we can get the high pressurized outlet here. Okay, here we can get the high pressurized outlet here. Okay, this is vent type supercharger. Next one is methods of supercharging. Okay, generally we are performing supercharging. Okay, for supercharging we require supercharger, means we require one type of compressor. Okay, but there are different methods are utilized for the uh, uh, performing the supercharging concept. Okay, means suppose we have one engine and compressor. Okay, but we require the power for the compressor. Okay, according to the power given to the compressor, there are different methods are used. First one is gear driven supercharger. Okay, means this is gear driven supercharger. Okay, means here in diagram we can see that this is the engine. Okay, this is the engine. Okay, this is the inlet for the engine, this is the outlet or exhaust for the engine. Okay, and this is compressor, means supercharger. Okay, this is the inlet for the compressor, this is the outlet for the compressor. Okay, that's in supercharging concept. In supercharger, the pressure of air increase and the high pressure air is supplied to the engine cylinder. Okay, but the power required for this compressor, the power required for this compressor or supercharger is supplied by the gear, is supplied by this gear drive. Okay, here gear drive used. This gear drive transfer the power from engine output shaft to the compressor. Okay, means here the compressor run over the power given by the engine through the gear drive. Okay, therefore this supercharger is known as gear driven supercharger. Okay, gear driven supercharger. Okay, so here gear driven supercharger, this is intercooler. Okay, what is the function of intercooler? Suppose in a compressor the air pressure is increased. Okay, in that same case there is temperature also increase. Okay, in order to reduce the temperature, here the cooler is used. Here the temperature is reduced, and this low temperature high pressurized air or air fuel mixture is supplied to the engine cylinder. Okay, this is gear driven supercharger, means this compressor or supercharger is driven by this gear mechanism. Okay, therefore this is gear driven supercharger. Okay, here the output power or resultant or net power of the engine is nothing but the difference between the power developed by the engine and the power utilized by the compressor for the compression purpose. Next one is turbocharger. Okay, here the second method of supercharging is turbocharger. Okay, in same way, here this is engine. Okay, this is the inlet of engine, this is the outlet of engine. Okay, here at the inlet of engine we are providing the high pressurized, that is high density air or air fuel mixture. The high pressurized air or air fuel mixture is prepared in compressor. Okay, this is the inlet air which is supplied to the engine, compressor, and this is the compressed air, that is high pressurized air. Okay, but here the compressor, for compression purpose, compressor or supercharger required the power. Okay, the power required for this compressor is supplied from the gas turbine. Okay, here turbo means here the power required for the compressor to run is supplied from the gas turbine. Okay, here gas turbine means this turbine operates on gas. Okay, so here for working of this gas turbine, okay, the power or the energy required for gas turbine, here the gas which required is supplied from the engine exhaust. Okay, during the engine exhaust, the exhaust which is coming out from the engine is supplied to the gas turbine, and this gas turbine convert uh, or develop the mechanical power, and this power is supplied to the compressor. Okay, again here compressor act as supercharger and provide the compressed air. Here the cooling takes place and the power, the compressed air is supplied to the engine, and the resultant power will be increased. Okay, this is turbocharger. Okay, the difference between previous method and this method is, in previous method the compression, the power required for the compressor is directly supplied from the engine output shaft. Okay, the power required for the compressor is directly supplied from the engine output shaft through the gear drive. Okay, but here the power required for the compressor is supplied from the gas turbine, and this gas turbine is operate over the over the engine over the engine exhaust. Okay, next one is coupled engine compression and turbine. Okay, third method of supercharging is coupled engine compressor and turbine. Okay, so here coupled engine compressor turbine. Okay, means here again this is our engine. Okay, this is the inlet of engine where the compressor air is supplied to the engine. This is the exhaust of engine. Okay, and next one, this is compressor. Okay, this is compressor. Okay, so here in this coupled engine compressor turbine, okay, means here both the means here turbine and engine power, turbine and engine power means here gas turbine and gear drive means here two powers are used for the compressor. Okay, the compressor required or supercharger required power. Okay, this power is supplied from the turbine to the compressor, or also here the engine output power through this gear mechanism is also supplied to the compressor. Okay, there what happen, the during the exhaust of the engine exhaust come to the turbine. Okay, the turbine, that is gas turbine, it develops the mechanical power. This power is supplied to the compressor or supercharger. Again here the compression of air takes place, and this compression air is supplied to the engine's cylinder through this intercooler. Okay, this is as usual. Okay, but in some cases we require more power, more power compressor, that is if you require more compressed air. In that case, suppose this turbine is not providing uh, sufficient power to the compressor. Okay, in that case if we require more power, in that case this mechanism will comes in action. Okay, this mechanism will come in action means here the exhaust, okay, the exhaust here the output power of the engine, through this gear mechanism is supplied to the turbine. Okay, and here this turbine this output power is supplied to the compressor. Okay, and the compressor develop more compressed air. Okay, next one is the last method of supercharging is gear driven supercharger and pre turbine. Okay, here again this is engine. Okay, this is the inlet of engine, this is outlet of engine. Okay, here this is compressor means supercharger, it required power for the performance means it require the power. Okay, the power for the compressor is supplied from this gearing mechanism. Okay, means engine output power is supplied to the compressor through this gear mechanism. Okay, and this uh, compressor or supercharger increase the pressure of air, and the high pressurized air is supplied to the intercooler. Okay, here the intercooler again here temperature reduces. Okay, and this low temperature high pressurized uh, air or air fuel mixture is supplied to the engine cylinder. Okay, here this is gear driven supercharger means this supercharger is similar to the first type of supercharger, but here additional is pre-turbine. Okay, means here the additional, okay, means here this in this supercharger we are developing the compressed air through the uh, power given by the engine shaft, but here also turbine is also utilized. Okay, this turbine develop here the exhaust gases supplied to the turbine. Okay, and this turbine also develop the mechanical power. Okay, this is nothing but gear driven supercharger and pre turbine. Okay, here the second part of unit number 4 is completed, that is supercharging. Okay, uh, the last part of this unit number 4 is remaining, that is engine emissions and control. Okay, we will study this part in next session. Okay, okay, thanks to all for watching this video. Okay, thank you everyone.